In this question, we have to find the de-Broglie wavelength. Formula of kinetic energy half mv square equal to 3 by 2 kT. Kb is Boltzmann constant and T is the temperature in Kelvin. So this is the kinetic energy formula. To cancel out, the V square will be 3 kT by m and root of it, where this is the speed velocity. So here de-Broglie wavelength is given by h upon mv. In the value of here m kt by m, root of it, or h upon m kbt. All the values here, Planck constant, root of 3 mass of electron, Boltzmann constant, and in Kelvin. सेल्सियस को केल्विन में चेंज कर लिया. Solve it. Getting by solving, this is the wavelength 6.2 into 10 to the minus 9. So option 1 is correct. In this question, particle A1 and A2 having mass m1, m2 having the same de-Broglie wavelength, then so here lambda de-Broglie wavelength is given by h upon mv or h upon 2me. Here m is the mass, v is the velocity, e is the energy. We take this one, lambda it's same, it means momentum P equal to mv is also same. It means m is less, v is more, and vice versa. If more, less. So m1 v1 must be equal to m2, momentum same. But here it is in the question m1 is more than m2. It means v1 is less than v2. Momentum is same. So first option is correct. Energy, mass into energy is also a constant quantity because lambda is same. If m1 is more than m2, E1 will be less than 2. Energy of 1 means energy of A is less than energy of A2. Option 3 also correct. So 1 and 3 both are correct. Student perform an experiment on photoelectric effect using the two materials A and B. A plot between the stopping voltage and frequency is given. We have to find out the Planck constant H for A and B both. We know the photoelectric equation H nu equal to work function plus EV naught. V naught is the stopping voltage. If we differentiate both sides with respect to frequency, then H equal to this 0 because constant है. E dV naught by d nu. This is called the slope of this curve. So for A, H is given E 1.6 into 10 to the minus 19 and slope of A is 2 minus 0. Change in y-axis voltage upon फ्रीक्वेंसी 0 पर 5 हो जाएगा और ये 2 पर 10 है इंटू फ्रीक्वेंसी 10 पर 40 3.2 अपॉन 5 10 पर minus 33 for B H equal to E 2.5 minus 0 upon 10 minus 10 into 10 per 40 solve it, it comes here 8 into 10 power minus 34 joule second. So here for A and B, option 2 is correct. Material A and B are having the threshold frequency 1.8 into 10 power 14 and 2.2. Identical photons of energy 0.825 electron volt incidenting on them. Then photoelectrons emitted in is A or B. We have to find energy equal to H nu. So nu will be energy divided by H, Planck constant, and energy here is 0.825 इलेक्ट्रॉन वोल्ट. इसको जूल में चेंज कर लिया. अपॉन प्लैंक कांस्टेंट 6.6 into 10 power minus 34. We solve it. Frequency comes here 2 into 10 power 14 hertz. We ejected called photoelectrons emitted from the surface if the frequency is more than the threshold frequency. So for material A, this frequency is more than threshold frequency of material A, so it will eject photoelectrons. But for B, this frequency is less than the threshold frequency 2.2 in 10 power 14. So material will not eject any electron from the metal surface B. Means option 2 is correct. In this question, electron of mass m with initial velocity v0 along x-axis, having the electrical field E0 along the y-axis. If lambda naught given by this de-Broglie wavelength at a given time t. So here the de-Broglie wavelength is given by h upon mv, where v is the final velocity after time t. So velocity along the x-axis, constant acceleration in y-axis only. So velocity y after time t using first equation. Vy will be equal to initial velocity 0 because it is moving in along x-axis. So at. A means acceleration divided by E naught means force by mass, and t is the time. So the final velocity is Vx square plus Vy square. This is the resultant velocity. V naught square plus E square E naught square E square upon m square and root of it. So de-Broglie wavelength h upon mv. अगर V नॉट कॉमन ले लेते हैं, नॉट बाहर आएगा, E नॉट स्क्वायर कॉमन लेने से, तो इट विल बी E स्क्वायर E नॉट स्क्वायर डिवाइडेड बाई V नॉट स्क्वायर m स्क्वायर. क्या बोल रहे हैं? लैम्डा नॉट इनिशियली. तो लैम्डा विल बी लैम्डा नॉट अपॉन रूट 1 plus E square E naught square E square upon naught square. So option 3 is correct. Hello, in this question, maximum frequency and minimum wavelength are produced by the 30 kilovolt electrons. So we know the energy is given by Q into V is the voltage H nu. So frequency is given as Q into V upon H. Q means electron, so 1.6 in 10 power minus 19. Voltage 30 kilo, so 10 power 3 volts. Upon H, Planck constant 6.62, 3 into 10 power minus 34. Solve the frequency is coming here 7.24 into 10 power 18 hertz. And lambda is the maximum frequency, so this is the minimum wavelength. C velocity of light and this. So 3 into 10 to the power 8 upon, you can see 7.24, 10 to the power 18. After solving comes 0.041436 nanometer or 0.041 nano. Option 1 is correct. If the kinetic energy of the particle is increased by 16 times, then percentage change in the de-Broglie wavelength. If the formula lambda equal to h upon mv, momentum h upon 2 me, m is the mass of the electron, is the energy of the particle, lambda 2 by lambda 1, h m both are constant. Mass of the particle, electron, whatever it is, constant, h constant, inversely proportional to root of E. Energy means this is E1 upon E2 of it. Reciprocal हो गया और 1:2 का रेशियो. E1 is, let E2 is 60 times increased. We cancel out 1 by 4. Say percentage change in the wavelength lambda 1 minus lambda 2 upon lambda 1 into 100, 1 minus lambda 2 by lambda 1 upon lambda 1. Take a common like 200, cancel out 1 minus 1 by 4 into 100 means 3 by 4 into 100 means comes here 75% change. So option 2 is correct. Hello, in this question, electron and the photon propagate in the form of waves having the same wavelength. So here the wavelength is given by h upon mv or p, linear momentum. If lambda is same, then p, linear momentum, is also. So option 2 is correct. In this question, wavelength 0.6 micrometer from sodium lamp falls on a photocell and causes the emission of photoelectrons. Stopping voltage 0.5. If wavelength reduces 0.4 micrometer, stopping voltage 1.5 volt. We have to find out the value of h upon E. We know the equation of say h nu or hc by lambda. Here lambda 2. So work function plus EV naught 2 and wavelength 1. No change in the work function. If we subtract, it will be cancel out. Hc 1 upon lambda 2 minus 1 upon lambda 1. V naught 2 minus V 1. You have to find h upon E. Means here V naught 2 minus V naught 1, the voltage, and नीचे आ गया lambda 1 minus lambda 2, lambda 1, lambda 1.5 minus 1, 3 into 10 to the power 8, lambda 1, 0.6 micro, 0.4 micrometer, lambda 1 means 0.6 minus 0.4 minus, cancel out, solve it, comes here 4 minus 10 volts in second. The value of h upon E. So option 3 is correct. Hello, in this question you have to learn it. The rest mass of photon is 0. So option 4 is a knowledge based question. Hello, in this question mass 1 milligram has the same wavelength as electron is moving with speed this. We have to find out the velocity of the particle. So if wavelength here is this, lambda wavelength, de-Broglie wavelength is h upon p or h upon mv. If lambda is same, it means linear momentum is same or mass into velocity product is same. m1 v1 equal to m2 v2. Velocity of the particle v2. So m1 v1 upon m2. m1 means the electron 9.1 into 10 to the minus 31 velocity of electron 3 into 10 to the 6 1 mass 1 milligram. So this is gram and kg. Solve it here. V2 will be 0.7 into 10 to the minus 18 per second. Option 1 is correct. Hello, in this question, minimum energy required, that is called a work function. If the energy equal to work function, the minimum energy required, it can be supplied either by thermionic emission or field emission or photoelectric. Means here option 4 is correct, because all the processes are there with which we can take out the electron from the surface. The necessary condition here is the energy required must be more than the work function of the material. The work function of aluminum, potassium and platinum are 4.28, 2.3 and 5.65. We know the work function equal to h nu naught. So threshold frequency and work function is the relation here. If work function is more, maximum for platinum, so threshold frequency also maximum for platinum. It means threshold frequency maximum for platinum more than aluminum 4.28, as work function in between, and minimum work function is 2.30 for potassium. So threshold frequency minimum for potential. So option 1 is correct. Sodium surface is illuminated by ultraviolet rays and visible light. So here Hc by lambda or h nu equal to work function plus Ev naught. Work function is given by h nu naught. Say this is a constant for sodium. It means if frequency is more than the threshold and frequency is more and more increases, so V naught increases. And frequency for ultraviolet rays more than frequency for visible light. If frequency more, so stopping voltage more. So stopping voltage more for ultraviolet rays than light. Means the option here is 2 correct. Hello, in this question, nitrogen molecule and temperature here is 300 Kelvin. Mass of nitrogen molecule means 2. Atomic mass is 14.0076 U, 1.66 into 10 power minus 27 kg. And we know kinetic energy half mv square is equal to 3 by 2 kT. So here we will be given as cancel हो जाएगा 3 kT by m, and the de-Broglie wavelength is given by h upon mv, h upon m जगह लिखेंगे 3kT/m और h/3kTm. Putting all the values here, lambda will be h 6.62 10 power minus 34 3. Boltzmann constant, temperature in Kelvin m, 2 into 14.0076, 1.66 into 10 power minus 27. तो सॉल्व करते हैं. It comes here 2.75 into 10 power minus 11. The first option is correct. In this question, we have to find out the kinetic energy or stopping voltage plot between the kinetic energy stopping voltage or and this frequency on x-axis. So this sort of graph is, because this is the threshold frequency below which there is no photoelectric effect, and if we increase the frequency, kinetic energy is so given by this formula plus EV naught or kinetic energy. Frequency increases, kinetic energy stopping voltage increases. Frequency is just equal to this, then there is no kinetic energy, just electron emitted only. And below with the frequency threshold, there is no photoelectric effect. So option 4 is correct. Hello, in this question, top voltage, stopping voltage is 1.5 volt in photoelectric experiment. The maximum kinetic energy we have to find. So here h nu equal to work function plus EV naught. Maximum kinetic energy is this. So we can directly find out this because stopping voltage is given electronic charge 1.6 10 to 1 minus 19 into 1.5. This electron volt 1.5 electron volt simple. So option 2 is correct. Here metallic plate exposed to white light visible. For which of the following colors the stopping voltage maximum? So here we know the formula for photoelectric effect in terms of wavelength is the incidenting energy of the photons, and this is the work function plus stopping voltage. Say if the wavelength is minimum, stopping voltage is maximum, and we know minimum wavelength for violet color. The minimum wavelength for violet color and maximum stopping voltage for violet color. So option 4 is correct. Hello. Graph is plotted between the stopping voltage and frequency. This is the graph between the stopping voltage or kinetic energy with the frequency. And this is the frequency called threshold frequency, below which there is no photoelectric effect. The product of the slope of straight line obtained here with the charge E. So we have to find out the E multiplied by the slope is H. As we know the equation, by differentiating with respect to frequency both sides, NH, this work function is constant, so 0, E dV naught by d nu, and this is called slope. So E into slope is H, Planck constant. So option 1 is correct. Photons of frequency nu incidenting on the two surfaces A and B, metal A and B, threshold frequency nu by 2 and nu by 3. The ratio of maximum kinetic energy of A and B. We know this equation H nu equal to for metal A, threshold frequency H nu by 2 plus kinetic energy maximum for A. So kinetic energy maximum for metal A given H nu minus H nu by 2. So answer H nu by 2. Similarly, kinetic energy maximum for B is h nu minus h nu by 3. So it comes here 2h nu by 3 for metal B. And we have to find the ratio will be kinetic energy of A upon kinetic energy of B, h nu by 2 upon 2h nu by 3. h nu cancel out, 3 4 jayega, 3 by 4. So option here is second. A photocell connected to the electrical circuit placed at a distance of d from the source of light. As a result of this current flows in the circuit. What will the current in the circuit when the distance is d by 2? Now we know the intensity inversely proportional to the distance square. So current is directly proportional to intensity current small or I. So we are taking current I. Current is directly proportional to intensity is directly proportional to the square of the distance. So current is inversely proportional to square of the distance. Suppose in case of 2 current I2, in case of 1 current I1, D1 square by D2 square. D1 is D in the question given, and D2 is what? D by 2. D by 2. That will be 2 पर गया तो 4 आ जाएगा कैंसिल होने के बाद. So here I2 upon I1 is 4 times. So I2 is equal to 4 I1. I1 here is capital I. So option C. In this question, kinetic energy of proton and alpha particle are 4 electron volt and 1 electron volt. We have to find out the ratio of de-Broglie wavelength. So here we know de-Broglie wavelength is given as h upon mv, lambda for proton upon lambda for alpha particle, h upon m mass of proton, velocity of proton. Can convert into 2me. E is the energy. So here 2m, m for proton, and for proton 4 electron volt energy, 1h2. For alpha particle, mass is 4 times, energy is 1 electron volt. Cut it out, 4, 4, everything is same, so 1. Means lambda of proton for lambda electron, this ratio is 1, 1. So option correct, everything will be cancelled.